Hello friends, my name is Dr. Nathaniel Sawyer. I'm a professional engineer with more than 12 years of experience in the industry. Welcome back to Pr the Engineer. In today's video, we shall be discussing ECSA Group A outcome for the engineering technician application for professional registration. This episode will help you understand how to demonstrate competency and successfully prepare your engineering report. Basically, we'll be looking at understanding the ECSA outcome, focusing on Group A for professional technician. Before we begin, please note that this presentation is based on my knowledge, experience, and research of the engineering registration process. It is not an official presentation from ECSA or on behalf of ECSA, but serves as a practical guide to help you navigate the registration process. The objective of this presentation will be to explain the Group A of the ECSA outcome for technician, and I will provide examples of how to demonstrate competency in the Group A outcome of your engineering report. In terms of a presentation outline, I will explain outcome under Group A, what the outcome consists of, what is expected of the applicant. Before we actually do that, we will have to understand what are the characteristics of a well-defined engineering problem. Then we are going to look at explanation and examples of demonstrating competency in those outcomes. The Group A of ECSA outcome focuses on engineering problem solving. These outcomes are designed to assess your ability to define, analyze, and develop solutions to a well-defined engineering problem. We will break it down into 3 outcomes as per the policy. Outcome 1, define, investigate, and analyze well-defined engineering problem. Outcome 2, design or develop solutions to well-defined engineering problems. Outcome 3, comprehend and apply knowledge that are embroidered in engineering practice specific to engineering technician practice. Now, we in previous presentation focused on well-defined engineering problem. What are the characteristics of a well-defined problem? A well-defined problem has the following characteristics. It's a clearly defined scope and constraints, requires standard engineering techniques, can be solved using established procedure, code of practice, has a defined outcome with measurable success criteria. Now, using the words as per the policy, the characteristics of engineering problem is, you need to ask yourself the following questions before you choose a well-defined engineering problem. Can the problem be solved mainly by practical engineering knowledge that are underpinned in related theories? If the answer is yes, then that is a well-defined engineering problem. What is the nature of the problem? Those are the questions you need to ask yourself when choosing a well-defined engineering problem that you are going to report on in your engineering report. Does it have one of the following characteristics? Are largely defined but may require clarification. Focused task within the engineering system are routine and frequently encountered and may be unfamiliar but familiar in context. The problem might be unfamiliar, but the principle to apply solutions are familiar in context. What is encountered in the solution processes? Do the solution have one of the following characteristics? Can it be solved using standard or prescribed way? Are they encompassed by standard code and document procedure? Requires information that is concrete and largely completed, but requires checking and possible supplementary information. What is involved in decision making? While solving the problem and evaluating the solution, does it have the following characteristic? Does it require practical judgment in practice area of evaluating solution, or does it have consequences that are locally important but not far reaching? If this answers is yes, then that problem is a well-defined problem. It's very important that you check your engineering problem, whether it's well-defined or not, because that will inform you whether you can use that problem or you cannot report on it. Now, let's go into outcome one. What does outcome one consist of? Outcome one focuses on define, investigate, and analyze well-defined engineering problem. In terms of outcome one, it's broken into 1.1 states how you interpreted the instruction received, checking with your client or supervisor if your interpretation was correct or is correct. Therefore, how do you demonstrate competency in this outcome? What is expected of you is that you clearly outline the specific work instruction or task provided. What was the instruction that you received? For example, it may be that you were required to design, investigate, or analyze. Then number two, what is expected of you is explain how you understood the requirement or scope of the task, including any assumption that you made. 3, describe the steps that you took to confirm your interpretation with the relevant parties, the client, your supervisor, or the project team, whether you understood what they were requiring of you, the task or the instruction that you were given. 4, highlight any collaboration or communication effort to ensure alignment with the project goal. These are the things that are expected of you in terms of demonstrating competency in terms of this outcome 1.1. Now, let's look at an example on demonstrating competency in this outcome. The project we are going to make reference to is a sewer reticulation project. Please note that this is an example. You are not supposed to copy and paste. However, use it as a guide to enlighten you in terms of demonstrating competency in this outcome. For example, for a sewer reticulation project, I received an instruction to design a system to replace aging pipe while maintaining service continuity. I interpreted this to mean designing for both structural durability and hydraulic performance. To confirm my understanding, I consulted with my supervisor and reviewed the project specification and client's requirements. I identified the need to consider maintenance access points, which were not explicitly mentioned, but were critical for a long-term functionality. This interpretation was confirmed in a meeting with the client and my supervisor. So you are basically repeating what instruction you received and how you understood it, and how you confirmed that your interpretation of the instruction was correct by confirming either through a meeting or through an email. Now, let's look at a second example, a road rehabilitation project. While working on a road rehabilitation project, I was instructed to assess existing pavement condition and recommend a suitable rehabilitation method. I interpreted this as requiring structural assessment of the pavement layer, the traffic analysis to determine the design traffic load. To ensure my understanding was correct, I reviewed the project terms of reference and conducted a meeting with my supervisor. During this discussion, I clarified that my scope included considering cost-effective solutions within the client budgets and prioritizing sections with high traffic volume. My interpretation was confirmed and I proceeded with the analysis. So you are explaining what instruction you were given and how you understood it and how you confirmed that your interpretation of the instruction was correct. It's very important. As an engineer, it's very important for you to understand the instruction, the scope of works, the terms of reference, for you to be able to come up with an informed solution. In outcome 1.2, describe how you analyze obtained and evaluate further clarifying information if the instruction was revised as a result. So you are expected to do what here? You are expected to demonstrate how you approach the problem analytically, to identify missing or unclear information, to describe methods you used to gather additional data, such as site visit, consultation, reviewing standards, or performing calculation. You are expected to highlight how you assess the information to ensure that it's relevant and accurate. You are expected to explain if and how the initial work instruction was revised based on the additional finding and how you communicated this change. That is what you are expected to demonstrate in this outcome. Now, let's look at an example. On the sewer project, I conducted site investigation to gather data on the existing pipe condition and flow rates, which revealed that certain sections were experiencing severe blockages. I reviewed SANS 1200 standards for guidance on pipe sizing, flow calculation. Based on this finding, I recommended revising the initial design to include larger diameter pipes and additional manholes for better flow management. This recommendation was approved by my supervisor and my client. Therefore, I incorporated the information into the revised project scope. So you're basically describing how you analyzed and obtained information and further revised the instruction based on your new finding. Now, second example, to analyze the problem on a road rehabilitation project. I started by conducting a detailed pavement condition, which included test and coring to determine the material property of the existing layer. I obtained historical traffic data from the municipality and projected future traffic volume using TRH4 standard. Upon analyzing the data, I identified that certain sections of the road were beyond rehabilitation but required reconstruction instead. I presented my finding to my supervisor, furthermore presenting it to the client, highlighting the structural inadequacy of this section and the need to revise the original instruction to include partial reconstruction. The client approved the revised scope and I updated the design accordingly. So you are basically explaining how you now investigated the information and how you analyzed the information and how you presented the new finding to your supervisor and the client and how that information influenced the initial instruction. Outcome 2. Outcome 2 focuses on design or develop solutions to well-defined engineering problems. Remember, we've explained what well-defined engineering problems are. Now, we are looking at designing or develop. Sometimes you might not be expected to design, but you might be expected to develop solutions in terms of processes, develop systems that might be used in terms of executing a task. What is expected of you here? Design or develop processes, clearly outlining the step-by-step process of how you approached solving the engineering problem. The analysis of alternative. You need to show that you considered multiple methods, multiple designs, and multiple analyses and their feasibility, and compare the pros and the cons for each of the options. You also need to look at the impact assessment. You need to highlight how you evaluated the impact of your solution, including technical impact, environmental impact, economical impact, and social impact. It's very important that informs the solution that you choose. In terms of technically, is it technically sound? Can this method be implemented? Number two, what is the impact of the solution on the environment? Number three, in terms of economical benefit, is it an economical solution? What would be the cost effect on the project of this solution? And lastly, the social impact. This solution that you have chosen, how will it affect the social aspect of that location? And you are expected to provide detailed calculations supporting your choice solution or demonstrating that there is technical competency in the solution that you are presenting and understanding of the problem. Now, let's look at an example to demonstrate competency in this out. Let's make reference to a water pipeline designed for a residential development. This project involved designing a 1.5 water pipeline to supply potable water to a new residential development. You are basically explaining the first step that you followed. The first step was to define the requirement. What were the requirements in terms of this project, which include the flow rate, the source of the pressure, the terrain in terms of hydraulic analysis. It's very important that you look at everything in terms of requirement. Multiple alternatives were considered. What were those multiple alternatives that you considered? In terms of the use of PVC, the use of HDPE, the use of ductile iron pipe, and also within that parameter, you can still look at the pipe diameters, a 150 pipe diameter, a 200 pipe diameter, a 250 pipe diameter, which will inform the hydraulic performance and the cost implication of the option that you have chosen. The hydraulic analysis. How do you perform the hydraulic analysis? Explain it. Which formula did you use to calculate the head loss for each material and pipe size? The friction loss. How did you determine the friction loss? What method did you use, or what formula did you use to determine the friction loss? Since there are various formulas available to determine the friction loss, what formula did you use in terms of ensuring accuracy of the flow condition? The velocity, how did you calculate the velocity? How did you calculate the head loss in terms of each and every option that you have made? Ensuring compliance with the recommended flow velocities and minimum pressure. This analysis revealed that a 200 millimeter HDPE pipe provides optimum balance of friction loss, durability, and cost. You can't just make that statement. You need to prove how you came to that conclusion. This is what is expected of you in this outcome. Remember, you are not looking at only one option. I know many of you will come and say option is to do nothing. A client has come to you to say, I have a problem, please provide a solution to this problem. And you present a solution as do nothing. That cannot be a solution. Do nothing cannot be a solution. You as an engineer, you are expected to come with a technically sound solution. Option of do nothing cannot be an option. In continuation, an impact assessment was conducted. Why was it conducted? A HDPE pipe was selected. For what reason? It was selected over a PVC due to their high durability and recyclability. So it reduces the environmental footprint. Remember, we are looking at technical, environment, cost, which is economy, and social. Every option that you come up with must come to that conclusion in terms of technical, environmental, social, and economic. So this approach ensured that the design was both technical and cost effective. Now let's look at a second example, the road rehabilitation of a 5-kilometer urban road. The project involved rehabilitating a heavily trafficked 5-kilometer urban road, which exhibited severe cracking, routing, and surface distress. The objective was to ensure ability while minimizing traffic disruption during construction. 3 rehabilitation methods were considered. Remember, I mentioned you need to look at various alternative approaches to do the work. In terms of solutions, different solutions. In terms of method, various methods. In terms of systems, what systems did you consider? What are the other systems you consider? In this case, you're talking about R with cement stabilization, resurfacing with asphalt overlay, and milling and overlay approach. Each option was analyzed for technical feasibility, cost effectiveness, and environmental impact. Now, in terms of continuation of that example we started, the road rehabilitation, the pavement design guide was used to calculate the required pavement thickness for each of the methods and also consider traffic loading over a certain lifespan. The cost benefit analysis revealed that while resurfacing was the cheapest option, it lacked durability. That was a technical solution, as it might be cheaper today economically, but it lacks certain aspect of technicality, which is durability. Looking at the milling and overlay offered a moderate lifespan, but involves significant material transportation costs. Remember, technical, environmental, economical, and social impact. Those are the things that informs your solution. Any solution that you are going to look at needs to be informed by certain factors, which we have mentioned. Calculation and drawing for pavement thickness material was provided. The traffic loading capacity was attached to the report to support the recommendation. Now, let's look at outcome 2, which is 2.2. State what the final solution to perform the work was. The client or your supervisor, were they in agreement? What is expected of the applicant here? The applicant needs to clearly state the solution implemented after considering all alternatives. This outcome wants you to demonstrate, after I have looked at all alternatives, what was the final solution implemented? In terms of the information that informed the solution, we've spoken about it, which is technical, environmental, economical, and social. The applicant is also to demonstrate alignment with the client or supervisor on the choice approach. Is the solution in alignment with what the client expects? Is the solution in alignment with what your supervisor would have chosen? That is important, because if your solution is in alignment, it shows that you have reached a level of competency in terms of decision making. Justification. You need to explain why the solution was selected. Ensure it meets the project requirements and addresses key constraints. Let's look at the example again in terms of the water pipeline design. After thorough analysis and consultation, the final design solution was selected, which was the selection of installing a 200 millimeter HDPE pipe to optimize performance and maintenance. I basically will explain that you located air valves in strategic high point. You also put scour valve. You also place pressure reducing valve in critical branches to regulate pressure and ensure consistent water distribution or water delivery across the network. This is demonstrating that you had critically looked at the problem and provided a solution to be able to address the problem presented. The client approved the design after presentation of the calculation, material options, the cost implication. The supervising engineer reviewed hydraulic analysis and validated, it's critical, validated that the design complies with all relevant standards and regulation. This alignment ensures that all stakeholders are in agreement and are confident in the solution. The water pipeline was successfully implemented, providing a reliable water supply while minimizing long-term maintenance costs. This is a demonstration of competence. You were presented with a problem, You came up with options and eventually chose one solution and presented it in a logical way for the client and for your supervisor to be able to understand. That is what is expected of the applicant. Rehabilitation of the road. The final solution involves full depth reclamation with cement stabilization for the base layer, topped with a 40mm asphalt wearing course. This approach balances environmental sustainability and cost efficiency. The supervising engineer reviewed the design and validated the calculation, while the client approved the proposal after presentation of the cost benefit analysis. Alignment with the project objective, the road rehabilitation was successfully executed, extending the service life of the road while reducing maintenance cost over time. This is what is expected of you to demonstrate competency in outcome 2.2 as a technician. Now let's look at outcome 3. In terms of 3.1, state what National Diploma Engineering Standard procedure and systems used to execute the work. What are the standard procedure that you have learned during your national diploma level that is helping you to execute the work, and how national diploma level theory was applied to understand and or verify these procedures. Basically, what is expected of you? You are expected to identify standard procedure and systems. The applicant must list and describe engineering procedures, standards, and systems they used in their task. This can be code of practice, this can be design standard, this can be specific systems, this can be software like hydraulic software, whatsoever is laid out or available to be able to execute or perform the task given to you. Application of national diploma level theory. You need to demonstrate, clearly explain how the national diploma theoretical knowledge was applied to understand, verify, or implement these procedures. This involves showcasing a sound understanding of the principle learned during your national diploma level. Here you need to demonstrate, link the solutions with the theory that you have learned at university. How was it helpful in terms of providing solutions to this problem? State what engineering principle, practice, procedure, methodologies, technologies, including application of theory, was applied in the practice area, including or indicating an understanding of other areas of practice that interacted with the practice area to underpin teamwork. What other teams was able to assist you in terms of executing the work? For example, the road rehabilitation project, you needed a geotechnical information, you need a surveyor, you need a project manager, you need different disciplines to be able to help you find solutions to that problem. Demonstrate knowledge and application of engineering standard, code of practice, legislations, regulation, and finance in the practice. You are expected to demonstrate that. Knowledge of application, knowledge of engineering standard, knowledge of legislation, knowledge of regulation, and knowledge of finance applicable in your practice area. Now, let's look at an example. During the design of water pipe system of the residential, I followed. You're basically showing that you apply design standards for the water supply and reticulation system. This project required determining the optimum size and ensuring adequate pressure at all delivery points. This was critical because you had to use hydraulic modeling software to simulate line performance under various demand scenarios. This helped verify compliance with the design requirements and ensure sufficient pressure at most critical points in the system. You are using an example of a project to be able to demonstrate competency and how you carried it and what standard, what codes did you use to be able to come up with those solutions. What software did you use to be able to develop solutions Remember, outcome 3 is talking about comprehend and apply knowledge that are embroidered in the established engineering practice. What knowledge are available? What engineering practice systems are available for you to be able to solve this problem? Now, in continuation of the water pipeline design for residential development, I applied the National Diploma knowledge of fluid mechanics or water engineering, particularly the Darcy-Weisbach equation. You are showing how you link your knowledge of National Diploma and solving this problem, which calculated pressure loss due to friction in pipeline. Additionally, I applied main equation when designing, for example, stormwater drainage to determine the appropriate diameter. So you are basically linking the theory you learned at school and the solution that you are presenting. This is to ensure that the system functioned effectively while meeting all regulatory standards, integrating theoretical knowledge with practical tools and standard allowed me to execute the design effectively and ensure compliance with best engineering practice. Now, in terms of outcome 3.2, give your National Diploma theory, National Diploma calculation and reasoning why the application of the theory is considered. What is it expected of you here? Provide calculation. The applicant must include detailed actual calculation performed. These calculations should demonstrate their ability to apply theoretical to real-world problem. You need to explain your reasoning, justify why the calculation and that approach was correct based on engineering practice. Now, using this example of water design for a residential development, you need to explain how you perform the calculation, show the actual calculations. Remember, you are supposed to show a snippet of the calculation, how you perform, and then the full calculation can be attached in the annexure. But here within the write-up, you can have a snippet of the calculation for you to demonstrate that you actually did apply your theory to the practical problem that you are facing. Unfortunately, for this presentation, I didn't include the whole calculation as it will require me to explain it, which will result in this recording being long. Therefore, you can continue in terms of the actual calculation if required. If your problem was similar to this example, you are expected to include your calculation. Now, in closing, where can you get help? You can reach us at Bridge the Gap Engineer. Our email address is admin@btge.co.za, and our website is as indicated on the screen. Reach us if you need any assistance in terms of compiling your registration document. Thank you for watching. If you found this video helpful, please don't forget to like, subscribe, and share with fellow engineering technicians. Stay tuned for more videos on professional registration and engineering career growth. See you in the next video. Thank you once again.